I can also use the distributive property. In this case, when we're using the distributive property, then that means that the first term would get multiplied into both parts, and the second term would get multiplied into both parts. Just like when we had the monomial. So it's going to be x times x plus 2 plus 3 times x plus 2. And we know that this is the same as x times x plus x times 2 plus 3 times x plus 3 times 2, because I would still need to multiply out into both parts for the second part. If I have two terms multiplied by two terms, there's going to be 4 multiplications that should be taking place. So what I actually have is x squared, 2x, 3x, and 6, and then I just combine my like terms. X squared plus 5x plus 6. For example B, this is going to equal a times 2a minus 1 minus 7 times 2a minus 1. A times 2a is going to give me 2a squared. A times negative 1 gives me negative a. Negative 7 times 2a gives me negative 14a. And negative 7 times negative 1 gives me positive 7. I combine the like terms in the middle, and I get 2a squared minus 15a plus 7. For example C, this is going to give me p times q minus 8 and negative 8 times q minus 8. When I multiply it out, p times q is just pq, p times negative 8 is negative 8p. Negative 8 times q is negative 8q, and negative 8 times negative 8 gives me positive 64, and there is no common terms to combine in this case. When I get to example D, same process. I have x multiplied by x minus 5y, and I have positive 4y times x minus 5y. X times x gives me x squared. X times negative 5y gives me negative 5xy. 4y times x gives me positive 4xy's. And 4y times negative 5y gives me negative 20y squareds. And once again, I have the xy's are like terms. I have x squared, I have a negative 1xy, and I have negative 20y squareds. For example E, if I have 9a squared times 5a cubed plus 6 and negative 1 times 5a cubed plus 6, then that's going to give me 45a to the 5 plus 9 times 6 is going to give me 54a squareds. Negative 1 times 5a cubed is going to give me negative 5a cubeds. And negative 1 times 6 is going to give me negative 6. And once again, no like terms in this case. Similar to the distributive property, we can also use what's called the FOIL method. The FOIL method means that I multiply together the first two terms in each set, or A times C, as we can see here. I multiply the outside terms, A times D. I multiply the inside terms, B times C, and I multiply the last term in each set, B times D. So if I'm using the FOIL method, I do the first terms, will give me x squared. The outside terms give me 4x's. The inside terms give me 6x's. And the last terms are going to give me 24. And then I have the like terms in the middle. So I have x squared plus 10x plus 24. For example B, the first terms, y times y, give me y squared. The outside terms, y times 2, gives me 2y's. The inside terms, negative 7 times y, gives me negative 7y. And the last terms, negative 7 times 2, gives me negative 14. And I combine my like terms again. Y squared minus 5y minus 14. For example C, first terms, 3x and x, 3x squareds. The outside terms, 3x and negative 5, negative 15x. The inside terms, 1 and x, gives me x. And the last terms, 1 and negative 5, give me negative 5. 3x squared minus 14x minus 5. For example D, be careful. Remember that 6a minus 5b squared is the same as 6a minus 5b multiplied by 6a minus 5b. It's the binomial multiplied by itself. And then once I expand it out like this, I can see that it will still follow the same FOIL rules. First terms, outside terms, inside terms, last terms. So when I multiply this out, it is going to give me 36a squareds minus 30ab minus 30ab plus 25b squareds. Combine the like terms, and I have 36a squared minus 60ab plus 25b squareds. And that's it. Go ahead, try some of the practice.